morning, guys. Today we are discussing dilations. This is a geometry type lesson. So if you think about when you go to the eye doctor, some of you, I have not gone to the eye doctor personally. I've not had a need to yet. So if you think about going to the eye doctor, a lot of you get your eyes dilated, which means they just take the little pupil and they stretch it out so they can get in there and see. Okay, so that's basically what this is. Now you could be stretching it to make it bigger, or we could be shrinking. Okay, dilation is stretching or shrinking. Actually, it's a stretch or shrink of an image. Okay, but it is important to note that we don't change the orientation of it. We don't change the location of the dilation, and we do change the location. We don't change. We don't flip it 360, 100. We don't. We're just making it bigger or smaller. And we're not even changing the shape. It's the same shape. They are proportional, okay? Dilations are proportional. So it's important for you to understand this. So we have here our D, our dilation, and then let's say K is our scale factor. Okay, so these shapes, we don't have any numbers plugged in for X and Y. So let's understand what I've got going on here. Okay, here's my original shape. This is my shape, whatever it is, bigger or smaller, bigger. This is my big shape. Its coordinates, we're just looking at one set of them, is X and Y, okay? Now, here is our dilation. If you notice, it's P, the same shape, but now it's what you call a prime. So it's P prime. All right, so what you do here is we just take this K, and we multiply the X by the scale factor, whatever that is, and the Y by the scale factor, whatever that is, okay? So that is part of our lesson today. That's the scale factor part, okay? Okay, so let's talk about scale factor. Here is just this regular shape I have. And let's talk about this. Okay, so when the scale factor, which is K, is equal to 1, there's no change in the shape. Okay, so if my scale factor is 1, the shape stays the same. Now, if I was to take my scale factor, so 1 is no change. So let's say I was to change about right here. We'll say that's about 3 over 2, 1.5. Okay, if you T-bowed that, turned it to a mixed number, that's 1.5. Or plug in your calculator. So that means that it is 1.5 times greater in size. You see what I'm saying? All right. If we went all the way to 2, that would mean that my shape is 2 times greater in size. All right. All right. So going past 1, and it can go, we could get bigger. We could go to 100. We could have a scale factor of 100 or larger. I mean, there's no limit to how large a scale factor can get. Okay. Now, if we were to, let me get a different color, peeps. Not that one. If we were to make the scale factor smaller than 1, so let's say we go, I don't know, here to 1/2. That would mean that my square or my shape, whatever it is, this just happens to be, is half the size of the original one. Okay, now I do want to let you know that you cannot have a scale factor of 0. If you go to 0, that shape is non-existent. So you'll never have a negative scale factor. So we could set that up and we could say that scale factor can be greater than 1. Oh, I'm sorry, I did this wrong. Okay, so I'm sorry. Maybe I did it right. Okay, so the scale factor has to be greater than 0. Cannot be 0. If you do 0, we have no shape. But it can be, I did it right, sorry, it can be greater than 1. So there's no limit in the restriction on how large we can make our shape. So just understand that right there. That's going to help you a lot. We're never going to have a negative scale factor, but you can have as big as you want scale factor. There is no restrictions on that. I was trying to make that clear. So Let's get into some examples. I will have to probably screen record them because I'm not real sure how I can draw a grid on here. Maybe I can. I don't know. We'll try. All right. Okay, so I could not get a coordinate. But what you will have is, you all know what a coordinate plane is, where you have the x, the first coordinate, second coordinate, third coordinate, fourth coordinate, makes a C. So they'll give you a shape. And we're just going to say we're dilating this shape. And we're going to perform the following dilation on triangle OMG. You like that? Okay. So our dilation is what we're performing. Here's our scale factor, K, which is 2 right here. So the first step you've got to do is find your coordinates. So you look on there and you remember that you go across the lobby to take the elevator up. So you go left first, left or right first, up and down second. Just think about that. All right, so let's say that our coordinates, let me find something. Okay, let's say our coordinates are, let's say O is, I actually wrote it down. So let me just look. O is -4, 1, okay? M is +3, 2, and G is 2, -2. Now, if you had a coordinate plane and you plotted these little dots and they connected, it would make a triangle. All right, so our scale factor right here is 2. So we already know, looking at that that's greater than 1, correct? So our triangle is going to get bigger in this change. So what we do here is we times 2. Right here, right here. We multiply by 2 here, here. We multiply by 2 here, here. Because what you do to one side, you got to do the other side. What you do the right, left, whatever. You have to make it even, okay? So our new coordinates for O, for the next triangle, would be -4 times 2, which is +8. Do you see how you need to know your negatives and positives and your rules? +2 times 1 is just 2. So the new coordinates for O would be 8. X would be 8. Y would be 2. M would be 3 times 2 is 6. And 2 times 2 is 4. And then G, +2 times 2 is 4. And +2 times -2 is -2. So that would be our coordinates for our next triangle. You would plot those and you would stretch them. You would actually, it would need to look a lot like the triangle you did here. If it does not, it needs just to be a bigger form. It would be like, if you think about Maddox and I. I'm her mother, and a lot of people say she looks like me with darker hair and darker eyebrows, whatever. She's just a dilation of me. She's a stretch of me. And currently, Maddie B, my youngest daughter, would be a shrink of me, a little one. So that probably wasn't a good example, but your triangle, your new triangle, needs to look like your other triangle, but in this case, since it's greater than 1, it needs to be bigger, okay? So we have a problem if your dilation turns out to be smaller. All right, so we're going to do something a little bit different this time. We're going to do a 4-sided figure instead of a triangle. And if you notice, we're going to construct the image of the figure, M-A-S-H, MASH. And we're going to construct, this means prime. So this is our new figure. The prime one's the new figure, okay? These don't have prime marks on them, so they're our original figure. And if you look, after our scale factor, our dilation is 1/3, okay? So this is less than this is less than 1. So this is telling me that my figure is getting smaller, okay? So it's less than 1. It's smaller than the number 1, 1/3 is, and so it's getting smaller. Now, there's 2 ways you can do this. You can multiply each of these numbers by 1/3, or we know that multiplying by 1/3, and you can use your calculator, so you can do whatever you want. And if you want to put it in your calculator, you can do parentheses, 1 divided by 3, close parentheses, and multiply it by -9. Or you can click alpha, y equals, or stat plot. It's the top left button. You can click alpha, the green button, and then go straight up to the very top left button, and you can plug in your fractions that way, picking number 1. All right, so I'm going to just divide these by 3 because I know the same thing, multiplying by 1/3 is the same as dividing by 3. All right, so we're going to, I'm dividing by 3, all of these, okay? I'm dividing by 3, all right? Because that's easier to me. I can do all that in my head mentally. Okay, so my m prime, -9 divided by +3 is -3. 3 divided by 3 is 1. Okay, so m prime is -3, +1. A prime. 3 divided by 3 is 1. 3 divided by 3 is 1. So that coordinate would be 1, 1. Okay, S. 3 divided by 3, S prime, sorry. 3 divided by 3 is 1, and -6 divided by 3 is -2. And then we have H. And -9 divided by +3 is -3. And -6 divided by 3 is -2. And that's prime also. So here are my new plots, my new little prime plots that I would plot. And it should be smaller when I got done. Should be the same shape. So just remember that dilating figures, they're proportional, so make sure that you're paying attention to the sides of it. And if you have questions, raise your hand. I'm going to try to do a screen recording real quick of some dilations. I don't know how well it will work on my computer, so don't hold me to it. If it's not at the end of this video, I am apologizing.